So guys, I'm just here in the river valley to film some of the supporting footage for my video to demonstrate, you know, how the drone is maneuvering and everything. And I gotta say that today, this morning, we have gusts up to 45 kilometers an hour higher up there, which is Hey, I lost the connection to the battery. I mean, the battery of my Sony camera went out, so I have to talk directly to my drone now. The light good here? Yeah, I'd say it's good enough. So it's actually quite amazing how well this works. Even with the wind blowing at it, the camera is stable. Can you see that? It's not shaking around much. When I fly it higher up there, it's moving around a bit more, but it's mostly just a drone and it's not the camera itself because it is on the gimbal and it works so well, I'm telling you. Anyways, since I'm already out here, I'm gonna go for a little flight, and yeah, I hope you enjoy the rest of this video. If you want to pass your basic exam, this video is for you. You're gonna learn something today. Today's topic sounds technical. RPA, Airframes, Powerplants, Propulsion and Systems. But really, it's just about how drones work. This is one of the sections of the basic Canadian Drone Pilot Certificate exam. And while it's not super hard, it helps to understand the big picture. So let's break it down. Airframes. The airframe is the physical structure of the drone. The body, arms or wings, and other surfaces. Its design affects the drone's speed, stability, and maneuverability. Most consumer drones are quadcopters. They have 4 arms with motors and propellers. And that's what I'll be focusing on. But Transport Canada wants you to understand the basics of fixed-wing aircraft and helicopters too. So a quadcopter has 2 clockwise and 2 counterclockwise propellers placed diagonally opposite. This setup generates lift while cancelling out unwanted spin. A helicopter works differently. It has 1 large rotor for lift and a small tail rotor to prevent uncontrolled spinning. A fixed-wing aircraft doesn't hover at all. Its wings create lift, but that works only when there's airflow, and that's why it always needs a runway or some other kind of strong throw. It also has control surfaces, ailerons for roll, elevators for pitch, and a rudder for yaw. A well-balanced plane can fly straight without any input, and that's called being trimmed. Here's one major difference. If the motors fail, a quadcopter drops like a rock, but a fixed-wing aircraft can glide. In fact, several real aircraft have landed safely without engine power, as long as they kept enough speed to avoid stalling. To learn more about this, I suggest you watch this video by the Mentor Pilot channel. It may just blow your mind. Now let's talk power plants. The power plant is what drives the drone, usually electric motors powered by a lithium polymer battery, LiPo for short. The motors are usually brushless, meaning they have fewer moving parts and they're more efficient and therefore they last longer. The propellers attach directly to the outer rotating part of the motor. LiPo batteries are light and powerful, but they can be volatile. Things like overcharging or deep discharging or physical damage can make them pretty unsafe. It's best to store them at about 50% of charge. Don't use a swollen battery. If a fire starts, do not use water. Use sand, a Class D fire extinguisher or isolate the fire until it burns out. Regular fire extinguishers may help prevent the spread, but they won't put out the fire. Most drone apps can show individual cell health. That's a good habit to check that regularly. If you're flying commercially or you're traveling with your drone, keep in mind Transport Canada and the airlines allow batteries under 100 watt-hours in carry-on luggage only. Most batteries that come with common consumer drones will be under that limit, but some larger ones may be above. So it's a good idea to check before heading to the airport. If in doubt, call your airline, and never pack any LiPo batteries in checked bags. They must be in your carry-on. Next subtopic is propulsion. It means turning battery power into movement. On a quadcopter, that's the motors and propellers working together. Propellers spin rapidly and bite into the air at a specific angle, creating thrust and lift. These propellers are actually pretty cheap, but they're critical. Inspect them before and after every flight. If you see any chips, cracks, or deformations, replace them. Also check the mounting mechanism. A loose propeller can cause a crash. Next it says systems. So what are they talking about? Well, this is where it gets interesting. For the drone to function, many components have to work together. That's what we mean by systems. They include flight control, navigation, communications, sensors, safety features. What about flight control and communications? Well, you control your drone using a ground station. This could be a remote controller, a smartphone or tablet running an app, or a combination of both. The controller sends radio signals to the drone, usually in the 2.4 or 5.8 gigahertz bands. These signals are affected by obstacles, interference, distance, and something called the Fresnel zone, where even nearby objects can cause disruptions. Many drones, like the DJI models, scan for interference and automatically switch channels. It works well, but nothing is foolproof. If you lose connection, try pointing your antenna toward the drone. If it doesn't work, try briefly turning off and then restarting the controller. And if nothing works, your return to home function should kick in, assuming it was set up correctly. All of this communication is handled by a transceiver, which relays signals between the controller and the drone's brain, the Flight Control Module, FCM for short. Okay, let's talk about Flight Control Module and sensors. The FCM takes your commands and translates them into precise actions using speed controllers for each motor, GPS, satellites to track the position of the drone, an altimeter, it's usually barometric to determine the altitude, gyroscopes and accelerometers to detect motion, a magnetometer, which is a fancy word for a digital compass that needs to be calibrated regularly, by the way, especially when flying in different locations. Helping all this work together is the IMU, Inertial Measurement Unit. It combines multiple sensors and gives the control module accurate data about orientation and movement. Calibration of the compass and IMU is critical, and you should log these calibrations as part of your maintenance records. Safety and obstacle avoidance. Hey, modern drones are loaded with safety features. Obstacle detection sensors. They're usually ultrasonic or visual. There are failsafe modes like the return to home, automatic landing, geofencing, low battery warnings. The camera is also part of the system. It is stabilized by a gimbal and can be controlled by the flight module based on pilot input and environmental data. Even the battery is part of the system. Smart batteries have embedded software that prevents overcharging, balances the cells, monitors temperature and voltage. Everything is coordinated, and when it all works, it seems so simple. But it's really not. It's a small miracle of modern engineering. Needless to say that if any of these systems is out of whack, failure of the entire drone is possible, resulting in things like flyaways or crashes. It's important that all the parts of your RPA system receive regular software updates and run on the proper versions that are compatible with one another. So, this is a high-level overview of how drones work. The airframe, power plant, propulsion, and systems. I'm hoping this will give you some clarity on what you need to know for your exam. I highly recommend using other resources to solidify your knowledge, some of which are linked in the description below. There are a lot of moving parts to a drone, literally, and all of them have to function together flawlessly. But don't forget, you, the pilot, are the most important part of the system. Your decisions, training, and awareness, and your skills are what make each flight safe and successful. That's why Transport Canada includes human factors on the exam, and that'll be the topic of my next video. Hey, I hope to see you there. And in the meantime, maybe you want to catch up on some of my other videos. And if you haven't subscribed yet, well, what are you waiting for? Can't lose. It's free. If you feel really generous and you want something that's not free, well, why don't you buy me a coffee? I know it's not free, but I like coffee. And by the way, liking this video is also free, and it may help my channel to reach a broader audience, which could benefit many people when they try to get their drone license, fly their drone safely, get the most out of their drone. You know the drill. There you go. And I'll see you soon.